Thank you, Brendan. Yes, I had an interesting experience. I went to a meeting with a psychoanalyst to discuss various issues recently, a one-off. And one of the disturbing insights I left with, and I'm not sure if it's true or not, was that I regarded myself as kind of being quite clever at trying to look under the stones and challenging shibboleths and stuff. But the feeling I left the psychiatrist was a question, is challenging some of the myths, and I hope to do that, is that just a residual effect of childhood anger? Well, I hope not, you know, or if it is, I'm channeling it. So what I want to do is question the value of mathematics. We're all mathematicians, we're all... it's funny that even using the word mathematician is inhibiting. But, you know, if you teach music, if you give music lessons, you're a musician, right? You don't have to be an ace solo violinist, you're a musician. Mathematicians, well, it's quite a guarded boundary. If you're not proving theorems, are you still allowed to call yourself a mathematician? Well, certainly we're all mathematics professionals. All my life has been involved with mathematics, teaching it, and it's a while since I proved anything. I want to question the value of mathematics. That thing we take as a great good, something we take for granted. Shall we stop for a minute and say, is it nothing but good? Now, mathematics is widely valued by us and beyond. As mathematics professionals, we greatly esteem and value mathematics. Mathematics is valuable in several ways, and I'll use this as an organizing framework for my talk, but in terms of its intrinsic value, its extrinsic, or by which I mean sort of synonymous with social value, and the personal value for individuals. So I'm dividing I'm not claiming that's complete, but it's a neat way of categorizing different domains for claims of value of mathematics. But I want to question the value of mathematics. Is mathematics an untrammeled good? Does promoting mathematics lead solely to beneficial outcomes? What are the actual, including unintended outcomes and costs of privileging mathematics in education and society? And even the talks at this conference alone have served to illustrate how privileged mathematics is in education and society. Dare we question the unquestionable? Dare we ask a question that is perhaps unquestionable in this company and ask, does mathematics cause harm? And there are some ways it might do. I mean, I raised earlier the issue, Catherine Crawford's idea that some Aboriginal peoples thought, it might be nice stuff, but I'm not going to let my people have this stuff in their minds because it could be polluting, it could be degrading to the human spirit. Well, so my three frames I talked about, first of all, the intrinsic value of mathematics. It's quite hard to find pictures to illustrate mathematical ideas, as various people have said. So I chose this kind of visionary picture of these wonderful flowers and abstract patterns coming out of someone's brain, representing the wonder of the intrinsic value and beauty of mathematics. Mathematics has an intrinsic value for its own sake. I think we'd all agree with that. It's a powerful exploration of pure thought, of truth, of ideas for their own sake. It's a wonderful, rich language for describing and modeling the world. So it has these assets, and that was, I just thought that was a nice picture to try and illustrate the wondrous things in mathematics. And here's another one I chose, the beauty of pure mathematics. Sorry, the beauty of pure mathematics. It's a wondrous world of beautiful crystalline forms that stretch off to infinity in richly etched exquisiteness, if that's a word. Quoting Hardy in Hardy's room, or the room dedicated to Hardy, like painting and poetry, mathematics has permanent aesthetic value. Mathematics possesses not only truth, but supreme beauty, a beauty cold and austere, like that of sculpture, according to Bertrand Russell. So there's no doubt it's a wonderful thing in itself. But let me look a little bit at the characteristics of mathematics. And being someone in mathematics education, I'm not only focused on, for me mathematics is not just research mathematics, it has a very big footprint in society, and most of that is in school. Oh, and society in general. And so I want to claim, I feel justifiably, calculation is central. It dominates the history of mathematics and the mathematical school. And calculation consists of rule-based procedures in which meaning is ignored. Not all the time, but the whole point of standard algorithms is that they're general, you carry them out. Also, algebra is central. The language of maths. It is the language of maths, and you know, beyond a certain point, everything has algebra. Well, most things are algebraic. Of course, there are diagrams in it as well. Algebra, of course, is variable-based, in which specific meanings are detached. Berkeley noted that as early as 1710. That in algebra, we leave the meanings behind. You may reattach them later, but so you can ignore meaning, you can put them aside. So there's a unique linguistic move. I claim it's unique, a linguistic move within mathematics, within mathematical language, from meanings to rules. And of course, there's a big payoff. This enables the miracle of electronic computing. Machines could not do mathematics if it wasn't that you could follow rules alone without any attention to meaning. Machines cannot understand meaning, but they can follow rules. But these characteristics of mathematics have costs as well. And the cost of mathematics, my claim, is that there are things that come with a mathematical way of thinking. It promotes detachment of meaning, ethical neutrality, separated values, I'll explain what that is in a minute, and a dehumanizing outlook. Seeing the world mathematically, well, I made this picture. I was trying to show how we turn some wondrous bit of nature through our perceptions and imaginings into a whole bunch of numbers. You get the point. We replace the beautiful complexity of nature with simplified models. A strength, but also in the wrong place of weakness. The separated values, these come from Carol Gilligan, and her description, they focus on, they valorize rules, abstraction, objectification, reason, dispassionate analysis, impersonality. It's called separated because, as opposed to connected, we're more human. Separated is where you're relating to things as objects rather than as people. And of course these values are intrinsic to mathematics, and furthermore are valuable and useful within mathematics. But in inculcating these values, we're fostering a dehumanized outlook in people. Separated values of mathematics, I use this diagram, I love diagrams and things, and for me the idea of this rather stern and cross male bureaucratic type figure thinking only in terms of right and wrong, for me that's quite a nice symbolization of this simplistic epistemology, separated values in action. Separated values may be necessary by the nature of mathematics. It is, after all, a process of objectivization, turning things into structure, kind of draining the color out. Well, literally, if you look at primary qualities instead of secondary qualities, you're looking at the measurables, and it's a very powerful tool. And within mathematics, and within its applications, as I'll say in a minute, these are necessary and beneficial. But beyond mathematics, these kinds of ways of thinking, these values, are unnecessary and potentially harmful. That's my claim. And I'll say a bit more. But now I'm moving on to my second theme, which is the extrinsic social value of mathematics. So that was the intrinsic, now the extrinsic. Mathematics is an essential foundation for, as we all agree, much of knowledge, especially science. It's the foundation for information and communication technology. Computing is wholly based on mathematics. Without Gödel and Turing, and I don't mean the incompleteness, but all his stuff with primitive recursive functions, getting things, mechanizing things, and I suppose you could say intuitionism and constructivism and all that stuff, and then Turing applying it to a machine, and then whatever followed, we couldn't have computing. That was pure mathematics. Pure mathematics that appeared unapplicable at the time. Well, I guess with Turing it started to look applicable. Information and communication technology are wholly based on mathematics. We also have a wide range of applications in engineering, technology, throughout society. And then linking with the last talk, economic, fiscal, and commercial life the basis of modern society fundamentally mathematical. It might seem trivial to mathematicians, it's all about numbers, although actually the derivatives and the complex things we were hearing about actually are not trivial. They're not as understandable. You know, you often say a lot of the arithmetic that we use in the street, any primary school child should know that by the time they're finished. Yeah?
I beg to differ, they are, but people present them complex. I can teach derivatives to 16-year-olds.
Okay. Okay.
But you don't make lots of money by saying they're simple.
Okay. But my claim is, however, that mathematics is an essential foundation, and this we agree on, for economic, fiscal, commercial basis on one side, at whatever level it needs to, or complexity it needs to be. And indeed work, study, and everyday life. These depend on mathematics. Utilize mathematics. And so to diagrammatize this in a way, we've got mathematics, I've got my foundation at the top, flows through science, into technology, the material basis for life, through computing, into media and knowledge systems, and through money, into social organization and trade. And I'm not claiming that's complete, there might be other further applications you could also argue for. Powerful. We live in a mathematized world. Again, I tried to find some images. People in a sea of numbers, a model of the universe as cogs and wheels and spheres and, you know, mechanical, if not quite mathematical. Coming back to some of the characteristics of mathematics, school, university and research mathematics are presented in sentences where the predominant verb is imperative. And Brian Rotman makes a nice case of this in his Ad Infinitum. Imperatives instruct or direct our actions, either inclusively, such as let us, or consider, or exclusively, such as add, count, solve, prove, etc. Operating mathematically is to follow imperatives. If you look at the text for the school children from 5 or 7 to 16 or 18, and then later on into university mathematics, we see a lot of imperatives. Almost all the verbs are imperative. Yes, I know there's a point where if you're going to become a good mathematician, you have to learn to jump out of the groove. You have to learn, and we discussed this, I think it was yesterday, the notion that you, if not tricks, the idea of being familiar with the rules and being able to operate beyond that. But fundamentally, even those people have been trained to follow the rules of mathematics. Operating mathematically is to follow imperatives, follow orders, carry out instructed procedures following rules unquestioningly. Later on you can question, but you can't question when you're doing your much vaunted long division, long multiplication. You've got to just follow the procedure. You start to question in the middle, the procedure will break down. So many procedures on signs are carried out with deferred meaning, as I've said. So this becomes a good training for calculative or instrumental reasoning, condemned by the Frankfurt School, the critical theory. Conducting procedures with no thought of external impact or ethical considerations. And I'm claiming mathematics is a great training for that. I suppose another good training for it was classics. Learning, the trouble is with classics, you're not just learning the grammar, are you? I mean, this was the preferred education of the ruling classes in the 18th century. But then you also engage in the literature in Greek and Latin, and that has a humanizing effect. So maybe the classics doesn't quite fit in the same way. And so, as you've already anticipated from the tone that that last page was reaching, I'm claiming there are negative outcomes of maths in society. That seeing objectivism in the sense of seeing things as objects, including people, a simplistic epistemology in terms of right or wrong, things are really clear-cut, instrumental reasoning in management and governmental thinking, ethics-free thought, and other, for example, educational ills that I haven't come to yet. Mathematics examinations as a sifting filtration device, which we've already discussed today. A fractional distillation of the population via school, class reproductive, and mathematics was tied up in sexism, less so now, but sexism was very supported by mathematics, although that is diminishing to some extent. So those are just a few of the negative outcomes of mathematics in society. Let me go through them a little more. Mathematics promotes this objectivism, a simplistic epistemology, and the world things are not absolutely true or false, as we like to think they are in the world of mathematics. I've shown the little picture of the man with his ticks and crosses again, and the simple choice between right and wrong. It's quite hard to find images to illustrate the abstract ideas, and this is the best I could do looking at Google Scholar or elsewhere. Decisions are complex and need to take account of the context, the social context, and human consequences, especially when we're talking about governance, management, looking after people's interests. And I'm saying that mathematics takes us away from that. Instrumental reasoning. Mathematics provides training in instrumental reasoning for management, for business, for governmental thinking. I mean, I'm not even coming to the idea of trickery that we perhaps, or dishonesty. I don't know if that was implicit in the last talk, but the notion, or maybe it's just
explicit in the last talk.
Obfuscation of stuff that's about the accumulation of wealth to a small group. Mathematics and instrumental reasoning, as well as mathematics directly, are implicated in that. And instrumental reasoning involves convergent, rule-following thought, inculcating separated values, a training in ethics-free and value-free thinking. All of those, I'm claiming, is delivered by mathematics, which we require our children to study from the age of 5 or 7. And now they're talking about age 2, at least to age 16, that's statutory. It's moving to 18, and then you can opt out of mathematics at 16, although it may be compulsory to 18. So I'm saying this has a big impact, a big footprint on the minds of our citizenry, our children, if you like. Instrumental reasoning, mathematics is the essence of instrumental reasoning. The focus is on means to ends and not on the underlying values. This is the Frankfurt School critique. Instrumental reasoning underpins management, corporate and governmental thinking. People are viewed as objects. Standardization, routinization, dehumanization lead to the unethical treatment of persons, according to Kelvin. And that fits in with this, my railing against instrumental reasoning as an incidental outcome of learning mathematics. Mathematics works as a fractional distillation device. We have a mathematics assessment system. We put children in on one end, and that end, sorry, I've got to reflect myself. And out of the top comes professionals, out of the next level down, skilled workers, out of the middle, lower, unskilled workers, and at the bottom, unemployed, underclass. And maybe the proportions of the valuable distillates will require a changing, as we heard earlier about the hourglass model, but mathematics success is highly correlated with career outcome. Of course, this is only a statistical correlation, but it's a very significant one. I'm not saying you've got a, you know, if A, then B kind of, but let's face it, without mathematics, it's hard to get a job as a professional. And without mathematics, you end up lower down the heap, usually. Social views of maths used to be sexist, they still are to some extent, but it was more dramatic, and here's some of the illustrations. The advert with the legs I'm showing was a government advert to encourage people to join teaching, and it says, the sooner you can spot where she's falling down, the sooner you can lend a hand. And guess what? Her sock, representing her attainment, is dropped on the math side. Although I will say, on the technology and science side, it's up, which is not so sexy. Nevertheless, maths is used to illustrate that. Another, and one could pick hundreds of these up, but these are a couple I've chosen. An advert for Let's guides to study. She's 11, she hates Brussels sprouts and maths, the A-team and maths, her younger brother and maths, lace-up shoes and maths. Maybe Let's can help. Just that association of problems, hatred of maths, failure at maths with femininity, that's an association that for too long has been widespread in popular culture throughout and within our preconceptions. It has diminished, but it hasn't gone away. I mean, there was a big change in the end of the 80s in school textbooks, where instead of all the girls being in a passive role and the boys being in an active role, were being less girls and more boys. Suddenly the publishers got told off And so suddenly they balanced it all out. But it didn't mean anything had really changed. It just meant that they had someone whose job it was to look through the math text before they were published and make sure they weren't sexist in the easy, overt way. Mathematics is the basis of money. This is the tool for the distribution of wealth. And as a tool, mathematics is implicated in the global disparities of wealth and life chances. Now, many people say, oh no, you can't blame mathematics for that. Well, but I think we should stop and think. Mathematics is that tool. It's that essence of value that is distilled out of the work, the hard work of people. It's a wholly fictional thing, money. It's not related to gold or anything. It's just part of a whole social framework. Mathematics is the lifeblood of that. And guess what? There are great disparities in who gains and who loses, and they're getting worse. And I've used that nice old picture of this pyramid with a big heap of swag at the top, representing the social classes, levels. So that was my second. I talked about the value of the intrinsic value of mathematics and its and some of the downsides. The extrinsic or social value. Now I'm coming to my third theme, the personal value of mathematics. Of course, there are great benefits. Mathematical knowledge empowers individuals to gain understanding, skills, reasoning, problem-solving capabilities, to gain qualifications for employment. So the first one is use value. The second one is exchange value. To be able to, individuals gain the ability to use mathematics in life and work. Some can express creativity through mathematics. Indeed, a lot of kids at school do express their creativity through maths. And for some who become professional mathematicians, that becomes a great creative outlet. And of course, mathematics provides a foundation for further study. But there are costs. Not everyone leaves with a big smile and a mathematical certificate. There are negative attitudes to maths. Many learners and adults are labelled as maths failures, they lack confidence, they fear mathematics. As mathematics professionals, you know that's true. Because how many cocktail parties have you been to where they say, what do you do? Oh, I'm a mathematician. Oh, really? I could never do mathematics at school. I hated mathematics, and algebra or fraction. Or the other one is, my little Johnny, he's having real trouble, you know, blah, blah, blah. The only thing worse would be being a dentist. So many learners and adults are labelled as maths failures. Ironically, research 20 years ago showed that kids at the top of primary school in Britain, maths was their favourite subject. I don't know how much that's changed. Something happens during the secondary years of schooling, the increasing abstraction of the subject, the exam pressure, and kids growing up as well, becoming adolescent and naturally shirty. But when kids leave school, and quite a lot of primary maths students who are training to be primary maths teachers, research I've done shows that a significant number have negative attitudes, and a minority are even maths phobic, but they have to struggle through it, and they're going to be ending up teaching it to future kids. And where it says recruits own up to child maths terror, that was an article from the Times Higher Educational Supplement talking about student teachers and how some of them feared maths. And I mean, there are courses, maths enhancement courses and other courses that actually can remedy that, but nonetheless, it's the way many are. And I couldn't resist this little picture in the middle, you know, Munch's The Scream, used to talk about maths. When is the test and what is the binomial theorem? There's a little book which has 100 different uses of Munch's The Scream in different contexts. It's interesting to look at that image associated with the recruit own up to child maths terror. Those are, well, not necessarily my age, but you know, we've got a few years on. You might remember Jimmy Edwards, a British comedian, and one of his comic roles was of a backward-looking school teacher. And here he's got the mortarboard, the gown, the stick. He's looking, glaring, pointing at the board, glaring at the audience, whoever they may be. And he's got Latin. He's got the top level is algebra, and he's looking threatening at you. And they Jim, your numbers up, Jimmy Edwards, the caricature-headed wacko, perhaps represent the stuff of trainee maths teachers' nightmares. And there's also a false image of mathematics that's communicated. partly through schooling and largely through culture. And it's seen by many to be a stern, unforgiving, joyless, authoritarian subject, a meaningless, formal subject learned by rote. And many people have the misconception that mathematical ability is an inherited gift, that mathematical advancement is not due to your own effort. In the West, it's different in the East. And there's a picture, it's quite old, and I've had to compress it a bit, so it becomes even stockier. And there's a stern maths teacher, again in the same garb, looking at you, the reader, and he's got this terrible maths question, and you've got to answer it, and you and I know that's not a question. X squared minus y squared equals x minus y times x plus y, x equals, there's no solution. But, you know, to the public, that is a threatening, the word this morning was gibberish. A false image of mathematics. You think, oh, well, that's an old-fashioned. People don't look like that. Maths teachers aren't presented like that, don't present themselves. But look, I had a primary, or one of my students had a primary school kids paint what they thought maths teachers looked like. That was a modern child's view of a maths teacher, again a bit foreshortened, I'm afraid. That was not acquired in school. That is a public image that has been, you know, that circulates. The stern, the big, the masculine. The child obviously had a bit of trouble with the geometry of the mortarboard, but so that's a modern child's view of a mathematician, which is not separated from a mathematics teacher. Bad images of mathematics persist. It's heartening to hear what we heard about media and how there's an improvement in the last 20 years, maybe, in the way maths is portrayed in movies, etc. Nevertheless, for many people, there are stereotyped and negative images that persist. So, those are my three domains. I talked about the good face of mathematics. This is Janus. I'm saying mathematics has two faces. In the good face, I talked about the benefit and value on my three domains, the intrinsic value of mathematics, the social or extrinsic, and the personal. But I'm also claiming there's a bad face that causes harm. And I talked about dehumanized thinking, instrumentalism and ethics-free governance, social reproduction, negative attitudes and negative image of mathematics. And like it or not, my claim is that those are outcomes of mathematics in society. But I want to claim that harm comes from a misapplication. I want to claim that mathematics is not intrinsically harmful, but its applications can be detrimental to many. It's the way it's portrayed, it's the experience of mathematics, it's the social image of mathematics, it's the way it's used. There's a way it's used to mystify, etc. I mean, there's an irony with mathematics. On the one hand, it's the most democratic subject of all, because you can always check the calculation or the proof. But it's also the most anti-democratic subject, because it's used to mystify, to obscure, that you're presented with a ready-made mathematization, and you're somehow not allowed to, or not encouraged to question what goes behind it. So it has those two faces there too. But I'm claiming, I'm acknowledging mathematics is not intrinsically harmful, but its applications can be detrimental to many. So how can we rectify this? And off the top of my head, I have some suggestions. This talk is like the page, and from that, it's too narrow for me to elaborate these too much, but I want to talk a little bit about these three proposals, to include the philosophy of mathematics with mathematics, to add the ethics of mathematics, and to reform school mathematics teaching and its curriculum and assessment. So going through those three, to teach the philosophy of mathematics, I think we should include the philosophy of mathematics in mathematics degree courses. And I don't mean teaching by intuitionists, logicists, and formalists. I mean looking at, you know, teach the limits of mathematical knowledge. It's how its certainties do not apply to the world. There's always a margin of error. Teaching epistemic and epistemological things about mathematics. Teach the limits of mathematical thinking, how true false dichotomies do not apply to the world. I'd have thought I was going to share, but I lost it. So that's what I think, that with mathematics teaching we should have concurrent courses that explain, that help to humanize future mathematicians and get them to think about the limits of their subject. And maybe a little bit of this at school. I think we need to teach the ethics of mathematics. We need to add the ethics of mathematics to mathematics degree courses. We need to teach the limits and dangers of instrumental thinking, its dehumanization of people and institutions. I think we must teach how mathematics must be applied responsibly, and it's wrong to ignore incidental outcomes or collateral damage in its social impact. I think we have a responsibility to teach and to no longer promote the myth that mathematics has nothing to do with ethics, that it's neutral, that it's value-free. I think we have a responsibility to make it an ethical subject. And of course, mathematics teaching, I could talk forever on this subject, and there are no easy answers either, but there are some things we can do, because I don't think we should get rid of hard work in mathematics. I don't think we should stop identifying mathematical talent and fostering it. Those would be terrible things to do, but I'm not going to stress those things today. I want to talk about how we can get away from the ills that I mentioned. I think we need to humanize mathematics teaching, that we have a duty of care for learners. Their maths attitude and images matter. And one way to do that is not to demonize errors. That it might seem like a joke when you mock someone when they make a mistake. Those kind of incidents are deeply damaging and persist for a long time, or may put people off forever. Errors are inevitable steps in learning, not sins or failures. So that's a very important step, I think, is to encourage errors and use them as a way for showing appropriate ways of learning and proceeding. I think we need to teach critical thinking, looking critically at social applications and mathematics-based claims. And I think we should add, the curriculum is mostly about doing maths. And I want to claim that we should add mathematical appreciation, maybe 10% of the curriculum, maybe less. I'm not talking about replacing what we do, to mathematical capability, the doing maths that constitutes the curriculum of today. The appreciation of maths one could explore more fully, but to teach kids that maths is more than calculating, solving, and proving, that school maths needs a broader appreciation of maths in culture, art, and social life, the history of mathematics and mathematics in history, mathematics as a unique discipline. What is special about it? For example, proof and how mathematical knowledge is validated. I think we could introduce controversies in the philosophy of mathematics. I think also, really importantly, we should introduce the big ideas of mathematics qualitatively. Not everyone needs to master post-Cantorian infinite set theory, but the idea of discussing infinity with kids, why not? Your average 9-year-old has an idea of infinity and can tell you, oh, the numbers are infinite, because you can always keep on counting. We should utilize those kind of interests, etc. So a few of the big ideas I've listed are pattern, modeling, symmetry, structure, equivalence, invariance, proof, paradox, recursion, randomness, chaos, infinity, and you may be able to give me some more ideas I could list there. Let's excite them. Some of these are part of the poetry of mathematics. That's it.